Hello friends, we have studied derivative of hyperbolic function in the last lecture. Now we shall study derivatives of inverse hyperbolic function. We know inverse of a function. Now when the inverse of a function, what is meaning of inverse of function and when the inverse exists. Suppose y is equal to fx is a function from say set x to set y. Then that means x, image of x is y, or we write this in terms of f of x is equal to y, and f inverse is the function from y to x, and in this case f inverse exists. We write this function by inverse image f inverse, and if this function is 1 1 and all 2, then the inverse exists, and this can be written as f inverse of y is equal to x. Inverse image of y is x. So that means these two are equivalent when the function is 1 1 and all 2, or imply each other. Y is equal to fx implies f inverse of y is equal to x, and vice versa. Now for example, we know the inverse trigonometric function. If we have x is equal to sine theta, then we can write theta is equal to, take this sine function on this side, it becomes inverse. So sine inverse of x is equal to theta, like this. So for example, we have sine of pi by 6 is equal to half, sine of 30 degrees half, and this can be written as, see, sine inverse of half, sine is transferred on that side, or that is pi by 6. Pi by 6 is equal to sine inverse of half. So that is the meaning of inverse function, and we know this inverse for circular functions. Now likewise we shall express the inverse of hyperbolic functions. That means if you have sine hyperbolic x is equal to y, then this x can be written as x is equal to inverse hyperbolic sine of y, and the inverse of hyperbolic function, other functions are also defined. So now we shall consider derivatives of these. Now see here, I have written the results about these derivatives as formulae. Derivatives of inverse hyperbolic function, we have to obtain these. First is derivative of inverse hyperbolic sine x, and that is equal to 1 upon under root 1 plus x square for x belongs to R. Similarly, the next result is d by dx, or derivative of inverse hyperbolic cos x is equal to 1 upon under root of x square minus 1, and so on. So these, because there are 6 hyperbolic functions corresponding to these 6 hyperbolic functions, there will be 6 inverse hyperbolic functions, and we have to obtain the derivatives of these, and we have to obtain these formulae. Now we shall consider one by one. First is derivative of inverse hyperbolic x. Now we shall suppose, let that be y. Let y is equal to inverse hyperbolic sine x, inverse hyperbolic sine x, and now we can consider, we shift this inverse function on this side, it becomes original function, hyperbolic function. Inverse of this inverse hyperbolic function will be the original function, and that is hyperbolic sine y is equal to x. This is the conversion. Y is equal to fx, we have seen, if y is f of x, then f inverse of y is equal to x, and but this is a inverse of inverse, means the original function, and if you shift the function sine hy on the other side, it becomes inverse, and from this also we can write y is equal to sine hyperbolic of inverse hyperbolic sine of x. So these two imply each other. Now why we have written like this? Because we have the formula for hyperbolic function. So inverse function is written in terms of the original function and then we differentiate it. Now this is actually x is equal to hyperbolic sine y, and this x is function of y, so therefore we differentiate this x with respect to y, and that is dx by dy, derivative of x with respect to y. What is the derivative of hyperbolic sine y? We have seen the derivative of hyperbolic sine x is hyperbolic cos x. Instead of x, here the variable is y. So derivative of hyperbolic sine y, or we can write this as d by dy of hyperbolic sine y, and which is hyperbolic cos y, or therefore dx by dy is hyperbolic cos y. Derivative of hyperbolic sine y is hyperbolic cos y and vice versa. We have obtained the formula for derivative of hyperbolic functions in the last lecture. You refer these formulae. We are using these formulae to obtain the derivative of inverse hyperbolic function. But what we have obtained is dx by dy. We want dy by dx, and we have the rule for derivative of inverse function. Dy by dx is reciprocal of dx by dy, or 1 over dx by dy, and 1 over dx by dy. So this rule of derivative of inverse function we have studied earlier standard, and therefore this is equal to 1 upon hyperbolic cos y. See, first we have converted the function in terms of x, and then we have differentiated x with respect to y. We have obtained dx by dy, but we require dy by dx, and therefore we have written dy by dx as 1 over dx by dy, and that is 1 over hyperbolic cos y. Now the final result, y is the original function or required function, that is inverse hyperbolic sine x, and we have the derivative of y here, but this is in terms of hyperbolic sine y, and here we have hyperbolic cos y. So we convert this hyperbolic cos y in terms of hyperbolic sine y. So this can be written as 1 upon under root of, and when we write root, there will be the possibilities of plus minus sign. So we have to write plus minus sign under root of cos hyperbolic cos square y. See, square root of square, root and square cancels, but there is plus minus sign. When we write under root, there are always possibility of plus and minus sign, and thus this is what we have obtained is dy by dx. Further, this is equal to plus or minus. Now what about hyperbolic cos square y? We have the fundamental identity. What is the fundamental identity we have? That is in terms of y, hyperbolic cos square y minus hyperbolic sine square y is equal to 1. And we want to convert now hyperbolic cos square y in terms of hyperbolic sine y, because our x is in terms of hyperbolic sine, not hyperbolic cos. So hyperbolic cos we convert in terms of hyperbolic sine using this fundamental identity. So this is the fundamental identity we have. And what is the value of this? Shift this term on that side, it becomes 1 plus hyperbolic sine square y, or that can be written as 1 upon root of 1 plus hyperbolic sine square y by the fundamental identity, or you may write as since hyperbolic cos square y minus hyperbolic sine square y is equal to 1. From this we have written this way, and again this dy by dx is, I shall write here, see what we have here, hyperbolic sine y is equal to x. Now we put this value of hyperbolic sine y as x for dy by dx, and thus the term becomes dy by dx is equal to next to this step I am writing here plus or minus 1 upon under root of 1 plus x square Now see, the square of x is square of hyperbolic sine y, and that is always positive, and therefore we take the positive root of this radical, and thus we can write hyperbolic cos y. So this is the sine, or you see, it is the above step to this is 1 upon hyperbolic cos y, and then hyperbolic cos y we have written in this form, root of hyperbolic cos square y. But hyperbolic cos y is always positive. What is the definition of hyperbolic cos y? It is e to the power y plus e to the power minus y divided by 2. And exponential function is always a positive function, and there is addition. So therefore this is greater than 0, positive. And thus it has a positive sign, therefore we should take the positive sign of this radical. But hyperbolic cos y is positive, and therefore we take positive sign of the radical. Radical means under root sign. The under root sign has plus and minus two signs. We shall consider positive and negative sign. We shall consider positive sign of the radical, and thus this can be written as dy by dx is equal to. Therefore, dy by dx is 1 over, taking positive. Now we don't write plus minus, we write only positive, divided by root of 1 plus x square. And this is our first formula. What is y? Y is sine inverse hyperbolic sine, and that is inverse hyperbolic d by dx of inverse hyperbolic sine x is equal to 1 upon root of 1 plus x square. So this is our first result, and thus the first result we have obtained, where x is any real number, x belongs to R. Now we consider the second. The same procedure we have to use for obtaining or deriving these formulae for inverse hyperbolic functions. Second result now. Consider y as the function to be whose derivative is to be obtained. Now y is inverse hyperbolic cos x. Second, suppose that y is equal to inverse hyperbolic cos x, and therefore what this gives, x is equal to, we interchange the side and shift this function, it inverse becomes original function hyperbolic cos y, and therefore we differentiate this x. Dx by dy will be derivative of hyperbolic cos y is hyperbolic sin y, and therefore this is hyperbolic sin y. This is dx by dy. Now we want dy by dx, and therefore we take the inverse of the reciprocal of this, that is dy by dx. Actually this is the rule of derivative of inverse function. Dy by dx is 1 over dx by dy, and 1 over dx by dy is 1 over hyperbolic sin y. And again we convert hyperbolic sin y in terms of hyperbolic cos y. What is the fundamental identity? That only the first fundamental identity we are using. It is in terms of y, therefore I am writing y. Earlier we have written it in terms of x. So hyperbolic cos square y minus hyperbolic sin square y is equal to 1. This is the identity in terms of y. And what is the value of sin square, sin hyperbolic square y? So this is, now we write as, when we write under root, we have to write the plus minus sign. Under root of hyperbolic sin square y. Why we are writing like this? Because we want to convert hyperbolic sine in terms of hyperbolic cos, in terms of x. Final result we want it in terms of x. Therefore we are converting sine in terms of x. We know that for circular functions cos square x plus sin square x is equal to 1. How do you write cos square x? 1 minus sin square x, and similarly sin square x is 1 minus cos square x. So like this conversion we are doing from sine to hyperbolic sine to hyperbolic cos, and therefore we are writing this in square form, but the value must not be changed, and therefore we have to write under root and square, and because root is there, there is always plus minus sign. So therefore this is plus minus 1 upon root of. So what is the hyperbolic sine square? Now shift this term on that side, it becomes positive, and 1 on this side. So that means hyperbolic cos square y minus 1 it will be, and thus this is equal to plus or minus 1 upon what is cos, hyperbolic cos y, hyperbolic cos y is x, so this will be x square, it is square, so x square minus 1, and this is what we have obtained is dy by dx. Now we see again, we consider this sign of hyperbolic sine y as positive, and therefore we take the positive sign of the radical. So taking positive sign of the radical, we get, and because there are two possibilities, plus and minus. When the hyperbolic function becomes positive and negative, that depends on the graph of the function. We have not discussed the graphs, and we now here consider positive sign. Taking positive sign of the radical, the expression can be written as positive sign of the radical. We have dy by dx is equal to positive 1 upon root of x square minus 1, and thus, so what is the final result is dy by dx is equal to 1 upon root of x square minus 1, and you see what is y? Y is inverse hyperbolic cos x, and that means it is d by dx of inverse hyperbolic cos x is equal to 1 upon under root x square minus 1, and here condition is for this function to be existing is mod x greater than 1. Otherwise, if mod x is less than 1, this will be negative and it will be imaginary. So that condition is necessary, mod x greater than 1. So this is our second formula. Now see the third. We have to obtain derivative of inverse hyperbolic tan x, and we write for that purpose, for the third, let y is equal to for the third, let y is equal to inverse hyperbolic tan x, and from this we can have x is equal to hyperbolic tan y. Shift this inversion on this side, it becomes hyperbolic function, hyperbolic tan x y, hyperbolic tan y, it is y. This is shifted on this side, and now differentiate. So differentiate with respect to x. So remember to write dx by dy, not dy by dx. We are differentiating x with respect to y, and the derivative of hyperbolic tan y with respect to y, we have obtained the formula. It is sec hyperbolic y into tan hyperbolic y, and therefore this is derivative of hyperbolic tan y. It is a sec square. It is sec square, or that means hyperbolic sec square y, and thus this is, or you may first write this is dy by dx of hyperbolic tan y, and dy by dx of hyperbolic tan y is hyperbolic sec square y. You refer the formula. It is similar to circular function. Derivative of tan x is sec square x. Similarly, derivative of hyperbolic tan y is hyperbolic sec square y, and thus this is dx by dy we have, and therefore we write now dy by dx. So therefore dy by dx is 1 over dx by dy, and that is 1 over sec hyperbolic sec square y, and thus dy by dx is, now how to write, how to convert this hyperbolic sec y. Hyperbolic sec y we want to write in terms of x, that means in terms of tan. Now how to write hyperbolic sec in terms of tan? Again use this fundamental idea. Divide this throughout by hyperbolic cos square y. and then this becomes 1, this becomes tan hyperbolic tan square y, and this becomes 1 upon hyperbolic cos square y means hyperbolic sec square y. So thus this is hyperbolic sec square y is 1 minus hyperbolic tan square y, and that is 1 upon 1 minus hyperbolic tan square y. You should note we are using the fundamental identity only. This single identity gives these formulae. And earlier we have, after definition of hyperbolic function, we have proved these, or we have seen these identities that we are using here. And you see, what is hyperbolic tan y? Hyperbolic tan y is x, and therefore this is d by dx means d by dx of hyperbolic inverse hyperbolic tan x y, tan x, inverse hyperbolic tan x, and that is equal to 1 upon, or this we shall first write 1 upon 1 minus hyperbolic tan y is x, 1 minus x square, it's square, and therefore y, we are writing the value of y as this inverse hyperbolic tan x, and this is equal to 1 upon 1 minus x square. And here the condition should be this x is must be less than, absolute value of x is less than 1, so that this will be positive, and thus this is our next formula. Here there is no radical, and therefore there is no plus minus sign. When we write radical means under root sign, then there is plus minus sign. And now the fourth one, y is equal to inverse cot hyperbolic x. That is our fourth result. Inverse hyperbolic cot x, and therefore what is x? X is hyperbolic cot y. This is transferred on this side. And what is the dx by dy? Derivative of x with respect to y. That is d by dy of hyperbolic cot y. Now what is the derivative of hyperbolic cot y? That is negative of hyperbolic cosec square y, and therefore this is minus, we have obtained this in last lecture, derivative of hyperbolic cot y minus cosec hyperbolic cosec square y, and again this is dx by dy, so we should write now dy by dx. Dy by dx obtained, we first y is converted to x, then derivative of x with respect to y is obtained, and now the inversion. Dy by dx, the law of inverse function, that is 1 upon dx by dy, and 1 upon dx by dy is, the sign we write separate, 1 upon hyperbolic cosec square y, and this is to be converted in terms of hyperbolic cot. Again use this identity. So here to get cosec y, we should divide by hyperbolic square of hyperbolic sine, and then this will be, if you divide by square of hyperbolic sine, this will be cot, hyperbolic cot square y minus, this is 1, and this is equal to cosec is equal to hyperbolic cosec square y, or therefore cosec square y, hyperbolic cosec square y is hyperbolic cot square y minus 1, and that is equal to minus 1 upon hyperbolic cot square y minus 1. And what is hyperbolic cot y? That is x, so write it here as minus. So what is dy by dx? That is d by dx, d by dx of hyperbolic inverse hyperbolic cot y, cot x is equal to minus 1 upon x square minus 1, and this is our fourth result. And here the condition must be this x, absolute value of this x is greater than 1, because x square minus 1 is there. This must be greater than 1, so that this will be positive term, and negative sign is separate. So this is our next result. Now the fifth one, take y is equal to last two results are remaining. We shall consider the fifth. Let y is equal to, that is inverse hyperbolic sec x, inverse hyperbolic sec x, and therefore this gives x is equal to hyperbolic sec y, inverse function. And now dx by dy, dx by dy is d by dy of hyperbolic sec y. And what is the formula for derivative of hyperbolic sec y? Derivative of hyperbolic sec y, that is minus hyperbolic sec y into hyperbolic tan y. Last time we have obtained this formula, you refer the formula. And this is dx by dy. Now we write dy by dx. So dy by dx is 1 over dx by dy, and that is minus sign we write separate, 1 over sec hyperbolic sec y hyperbolic tan y. And you see now we have here, what is the value of x? The value of x here is hyperbolic sec y. So this hyperbolic tan y we again express in terms of hyperbolic sec y, and that is dy by dx is, and for that purpose we have to write it in terms of under root of tan square. So this is minus, and here we shall write this minus sign above at numerator, minus 1 divided by plus or minus sec hyperbolic sec y into under root of hyperbolic tan square. This plus minus sign is written for radical. Root of tan hyperbolic tan square y is same as hyperbolic tan y. Now what is the value of hyperbolic tan? Here we have to divide by hyperbolic cos square, and then that becomes 1 minus hyperbolic tan square y is equal to hyperbolic sec square y. And therefore tan square, hyperbolic tan square y is 1 minus hyperbolic sec square y. We write that value here, that is minus 1 divided by plus minus hyperbolic sec y into under root of 1 minus hyperbolic sec square y. Yes. And now put the value of hyperbolic sec y as x. So therefore this becomes, this is equal to dy by dx is minus 1 divided by plus or minus x into under root of 1 minus x square. Now the sign of this is same as sign of hyperbolic tan y, and that means here it is under root of tan y and hyperbolic tan y, and therefore the sign of hyperbolic tan y is positive here, because we are considering mod x is less than 1. But the sign of radical is same as that of, what is the radical is for tan. So therefore the sign of radical is same as that of hyperbolic tan y, which is positive. And therefore we have take the positive sign of the radical, means this is positive and this negative remains separate, that does not change. So this sign is to be taken as, between positive and negative we take positive sign, we don't change the sign at the numerator, and therefore this is minus 1 divided by x into under root of 1 minus x square, and this is the condition is mod x is less than 1 because of 1 minus x square. This is our further formula. And but what is the dy by dx? Dy by dx means d by dx of y. And what is y? Y is inverse hyperbolic sec x, and this is our next formula, this one, you see. So this we have obtained. Now the last one, that is 6. Let y is equal to, we are using the same procedure, you should understand, and we are using, first we are obtaining the value of dx by dy, and then we are expressing it in terms of dy by dx as a reciprocal of dx by dy. So 6 result, let y is equal to inverse hyperbolic cosec x, and therefore this gives x is equal to cosec, that is hyperbolic cosec y, and therefore dx by dy is d by dy of hyperbolic cosec y. And what is the derivative of hyperbolic cosec y with respect to y? We have the formula minus negative of hyperbolic cosec y into hyperbolic cot y. This formula we obtained in last lecture. This is dx by dy, but we want dy by dx, take the reciprocal, 1 upon dx by dy. And we take the minus sign at numerator and write this at the denominator. That is hyperbolic cosec y into hyperbolic cot y. And you see this is equal to minus 1 divided by, we keep this as it is and we write this in under root sign, and therefore we write plus minus sign. Plus minus hyperbolic cosec y into root of hyperbolic cot square y. Why we are writing? Because we want to convert hyperbolic cot y in terms of x, means hyperbolic cosec y. And you see from this hyperbolic cot square y can be obtained by dividing by hyperbolic sine square. So here we get hyperbolic cot square y minus 1 is equal to hyperbolic cosec square y. Easy to verify these results. And thus this hyperbolic cot square will be hyperbolic cosec square plus 1, or that is minus 1 divided by plus minus hyperbolic cosec y into under root of hyperbolic cosec square y plus 1. And now we convert it in terms of, or we write this as x. We have hyperbolic cosec y is equal to x, and thus dy by dx becomes, now see, now I shall write here, we have obtained these formulae. So therefore this further becomes, this last result, dy by dx is, dy by dx is equal to minus 1 divided by plus or minus. Now or before writing plus minus sign, we shall check the sign of this. Now what about this plus minus sign is for this under root, that means for this term, and that means for this term, hyperbolic cot y. And hyperbolic cot y, the sign of hyperbolic cot y is same as that of hyperbolic cosec y, and this is positive. Hyperbolic cosec y is positive when x is positive, that this is positive. Why it is so? Because hyperbolic cot y, you see, hyperbolic cot y is hyperbolic cos y, hyperbolic cos y divided by hyperbolic sin y. This is hyperbolic cot y. And what is hyperbolic, this ratio, actually this ratio is, I shall write here, this ratio is e to the power y plus e to the power minus y, negative y, divided by e to the power y minus e to the power negative y, by definition of hyperbolic functions. And this term is sum of the exponential function is always positive. And but this, because there is a difference, this is positive, but the difference of two positive numbers may be negative, and therefore this may be positive and negative depending on which is greater. And therefore we should have this this will have positive or negative sign. Hyperbolic sine y will have, and thus hyperbolic cot y sine depends upon 1 upon hyperbolic sine y, means cosec, hyperbolic cosec y, and that means x. So the sign of hyperbolic cot y depends on x. That is the meaning. 1 upon hyperbolic sine y, that means x. So that we will write as, so this is, first we convert it in terms of x, x under root of x square plus 1. But the sign of the radical is positive when, but the sign of the radical is the same as that of this radical is for cot hy, you see, and therefore its sign will be same as hyperbolic cot y, is same as that of hyperbolic cot y, and hyperbolic cot y sign is same as x, whose sign, and again, or you may write again, the sign of hyperbolic cot y is same as that of hyperbolic cosec y, and that is x, hyperbolic cosec y, which is equal to x. So therefore if x is positive, the sign of the radical is positive, and x is negative, the sign of the radical is negative. So therefore if x is positive, or the sign of the radical is positive or negative according as x is positive or negative, that we can write. Therefore the sign of radical is positive or negative according as x is positive or negative. If x is positive respectively, then radical is positive, and if x is negative, the radical is negative. Or therefore we write this as dy by dx is equal to, it has two values. First positive, we consider x is positive, and then it has positive sign, so that will be -1, we keep fixed, and this sign is positive, means we have to write positive value of x plus sign x into under root of 1 root of x square plus 1. If x is greater than 0, and second thing, it is minus 1 divided by, there are two possibilities, positive and negative. The sign is positive when x is positive, we have written positive sign of this. Now we have to write negative sign if x is negative, and in that case it is minus under root of x square plus 1. Now we can combine this, only the change is for now happening here for x. X is positive, then it is x. If x is negative, then it is minus x, and that is the definition of mod x. We know mod x is x only when x is greater than 0, and mod x is minus x or negative x when x is less than 0, and therefore we write these two together results together as dy by dx is equal to, so therefore dy by dx is equal to minus 1 divided by mod of x together under root x square plus 1. And here either x is greater than 0 or x is less than 0 means x is not 0. Either greater or less but not 0. And this is what is our last result, you see. And therefore derivative of y means inverse hyperbolic cosec x, and its derivative is minus 1 divided by mod of x under root of x square plus 1 when x is not equal to 0. So you should remember these results as a derivative of hyperbolic functions. So in this way we have obtained the derivatives of hyperbolic functions using its inversion actually, and using the derivative of hyperbolic function. We have used the derivative of hyperbolic function to obtain the derivative of inverse hyperbolic function, and we have used the derivative of inverse function rule here. So this is about derivative of inverse hyperbolic function. So remaining part we will continue in the next lecture. Thank you.